I'm not going to give that spiel again, but yeah, this is your chance to ask the questions and see if it helps you. Okay, 23. This is Leithold 3.6. This is your day to say, Mr. Evans, work a problem for me. Because you're supposed to have tried to work a few of these during your hour yesterday. How many of you actually put in a little time yesterday? Anytime? All right. I like honesty. Good. Now, 23 has derivative with respect to y. So the derivative of y will equal 1 because it's derivative with respect to y. Now, we'll put my little parentheses. Y minus 7 over y plus 2, all in parentheses, squared. And I think they put brackets around that too to make it where it's d, y, yeah, all of that. That's getting a little complicated for me. All right. Do you see how you have everything in parentheses with the power of 2 above it? Right? Well, then start off using your power rule. Now, yesterday we started off on some using our product rule. But notice on those, not everything was in parentheses with the power above it. One part had a power above it, and then what? Another part had a power, right, an exponent. Here, we've got it all in parentheses with an exponent. So we're going to bring the 2 to the front. We're going to write down y minus 7 over y plus 2. We're going to subtract from that 2, which is going to give us a 1, power of 1. Then we're going to put this in parentheses, and we're about to do a big what to what's inside the parentheses, a big quotient rule. All right? Someone always says, well, could you have just made the numerator y minus 7 squared and made the denominator y plus 2 squared? You could have it, it would be easier. All right? Do it this way. Now, denominator, y plus 2 squared. Y plus 2. The derivative of y minus 7 gives you a 1. I'm going to write the 1 down. Derivative of y with respect to y is 1. Change in y with respect to change in y. 1. It's fraction. dy over dy. A little hint for the future. Minus y minus 7 times 1. And then, let's chat for a second. Do you see how you have y plus 2 squared here, and you have y plus 2 to the first there? So that's going to be what in the denominator? That's going to be y plus 2 to the third. Don't ever square that out. Just leave it, but you can put that together. And then you have the y minus 7. And then what am I going to do? I'm going to simplify that numerator. It's going to be y minus y. And then 2 minus a negative 7 is going to be how much? All right. Big part I'm pushing is right here. Y plus 2 squared, y plus 2 to the first, y plus 2 to the third. All right. Thumbs up. Thumbs up. I see a lot of you. Everybody happy with that? Okay. How about 14? Be okay if I work 14. You think that might help you? Look at one of the trig ones you'd like to see work. Pick out some kind of trig problem up there you'd like to see work. 33. 33. Man, it's got 33. Okay, 33 trig. We'll do that. Now where you see it, 33, big trig. All right, and I'm going to have to erase this because I only got room on my camera, I think, for one side of the board. Okay, ready? That's with y, so it's all going to be in terms of y, equals 33 3 sine 2y. And in the denominator, you have cosine squared 2y plus 1. And I would probably have put that in parentheses, like so, but you don't need to. You know the plus 1's not, it's just the cosine of this part, right? Okay, it's just the cosine of that part. All right. Well, I am looking at a massive quotient rule, right? I'm looking at a quotient rule that's probably not going to be a lot of fun. How do I know it's a quotient rule? It's got a big old fraction bar in there, right? Big fraction bar, quotient rule. So f prime of y equals, write the denominator down squared. Then write the denominator down in front. Take the derivative of the numerator. You do not have to use the product rule because that is just a what out front? Just a constant. Okay? And what is the derivative of sine u? Cosine u du. What is the derivative of sine u? Everybody say it.
Cosine u du.
Okay. So we get 3 cosine 2y times 2. Derivative of sine u is cosine u, and then just don't forget the du on the end. When you learn those rules, I was teaching you part of the chain rule then. We just didn't tell you that. Okay? Then you got to put your minus sign. Then you have to write down the numerator. And I have to put that in parentheses or it just doesn't look right to me. And then I have to take the derivative of the denominator. Okay, see that 2 right there? See that? That's implying all of that is in parentheses with a 2 above it. We talked about that yesterday, right? Did we really? Or 2 days ago? Okay? So, I bring the 2 to the front. I'll write down cosine 2y. And it is now to what power? To the first. But then I have to take the derivative of that cosine u. And what is the derivative of cosine u? Everyone say it. Derivative of cosine u is?
Negative sine u.
Everyone say it. Negative sine u du. I'm glad I'm not at a concert and I'm trying to get people to sing on the front row, you know, and all that for, you know, how they try to get you to sing at the concerts. Negative sine 2y times another 2. Don't forget the 2 out there on the end. Ooh. Okay. We're going to do a little helpful stuff here. Okay. There's our denominator. There's the derivative of our numerator. Okay. Minus, there's our numerator, and then this is the derivative of the denominator. If I ask you what is the slope at y equals pi over 3, you could just put pi over 3 in there and find the slope, right? If you knew your what? Unit circle. Someone says, what are you going to do about simplifying that? It's a good point. Let's see what we can do. Yeah, that's the hard part, is the simplification. If I were simplifying this, probably I would try to start out really just without getting too carried away. I would take my numerator and I would not multiply these two together. I keep wanting to in my head, but I'm not going to. I'm going to take that and make that cosine squared 2y plus 1. But then I am going to make this what? 2 times 3, which is 6. And then I'm going to get another cosine 2y. And y'all keep seeing how I keep wanting to distribute that into there, right? Is that okay? But I'm not going to do it yet. Now, if you look over here, I've got a negative here, but I also have a what? Negative. So I can get a big old what out of that? Get a plus. Then, I think I'm going to go ahead and combine the 2, and that, and get 12. And, oh, I am kind of happy here. Look what I got here. Sine 2y times what? Sine 2y, right? Is that fair? I'm looking at my front row rating for some kind of positive. Okay, sine 2y. There it is squared now. And then I still have my cosine 2y. All over the denominator, which Mr. Evans almost said just write the word denominator down there, but I can't do that. Remember, if you try to take any more shortcuts than what I do, it's going to be bad. Now, if I look at my numerator, there's some things that will factor out of that numerator, aren't there? Look at your plus sign right here. And look, cosine 2y here on this side of the plus sign, right? And what do you have over here? Cosine 2y. I keep looking at this 6 and wishing it was 12, but it's not. Okay, so I can definitely take out cosine 2y. Let's do that. Let's take out. Now, this is where if I were doing it on my own, I would put a plus sign and I would line it up right under that plus sign. Okay, because you're going to be moving things out of that fraction. But I can't do that. So I'm going to put my plus sign here, put my bracket, and I'm going to take the cosine 2y out here and the cosine 2y out there. Divide those out, factor them out, cosine 2y. Someone says, well, you could also factor out a 6, right? Is everybody okay that you can factor out a 6 over there? We'll do that. So that's going to leave 2 sine squared 2y and that's going to leave cosine squared 2y plus 1. And I can drop the parentheses now because I'm not really multiplying it by anything anymore, am I? Right? Because if I'd have distributed out the cosine 2y there, I'd had cosine 2y there, and I'd also had what? Cosine cubed there, right? But I went ahead and factored it out, so it leaves that. And that's not what I wanted to happen. What I was hoping to have happen was that this was going to turn out to equal 1 in here. You see? Cosine squared 2y plus sine squared 2y would equal 1, except, well, I got a little problem. I got a what right there? 2. And I didn't want that 2. Yeah, I didn't want that 2. Someone's saying, well, you know, it probably should work out a little bit more. So we're going to draw our line. We're going to put our parentheses, cosine squared 2y. Those parentheses plus 1. Was that one originally squared right there? Okay, yeah, we're okay. Yeah, it's got a square there and a square there. All right, please do not ask if you can divide those out. Can you divide those out? No, because it's all that plus what? That. Now, if you could factor that out and put it over here, then you could divide it out. But for right now, you are out of luck on dividing it out. Now, someone says, maybe change this into 1 minus cosine squared 2y, right? And see if that simplifies. And it might. It might. I probably would stop there. But since I'm trying to get you to learn trig and make sure that you're happy with your trig, let's see what Mr. Leithold did. Number 33. We will cursor down and see how close we are to what Leithold says we should have. He says we should have 6 cosine 2y in the front And then he says the part in parentheses does simplify a little bit. Okay? And he changed it all into sine squared. He took the cosine squared 2y there and made it 1 minus sine squared 2y and combined them that way. If I would have done that. I would have changed the sine squared into cosine squared if I was going to simplify it anymore, so that everything would be what? Cosines. Okay? But if you're there, all he did was take the cosine squared 2y there in the front of the bracket, change it to 1 minus sine squared 2y, collect like terms. Now you say, well, do I have to do that on a test? Don't worry about the test. Worry about, do you have it simplified enough you could work with it? Honestly, if you had that, you could work with it. Okay? And, you know, this is not absolute perfection when you're simplifying. It is the idea that we've got something that's workable, and we could get it to what he has just to make us feel good. Right? Okay. So, makes me feel better. All right. Now, we just did 33. Let's skip down here. Let's look at, this is 3.7. 3.7. Oh, let's just go ahead and get down here at the very bottom. I want you to look at 3.7, number 23. 3.7, 23. 3.7, 23. Give it a shot. You give it a chance to see what you can do. 3.7, 23. 3.7, 23. See what you can do with this. For those of you that are watching at home, this is a chance for you to try to work it, or go get coffee. Moment or two. I promise not to do like my college professor, Dr. Daddy Butler, and tap on your desk and laugh at you if you're doing it wrong. He would walk around, look at what you were working on an exam, and tap your desk and laugh if you were doing it wrong. I don't want to hit pause. I may not know how to pause it. Okay. Just let it run. We just watch this part move. Does everybody agree we're doing a big product rule, though? Big product rule. Okay? I'm going to help you out on the fact that it is a product rule right here. Okay? So you have to do derivative of the first times the second, and then a big old what? Plus sign, then the first times the what? Derivative of the second. Yeah. Give you a few minutes, and then I'll put the derivative on the board so that you can check your derivative. And then you can check your simplification. You got a big plus sign in there somewhere, right? Yeah. You don't have a big plus sign somewhere in your problem after you take the derivative. You're definitely wrong. Got to be a big plus sign in that derivative. Because it's what? Derivative of the first term, write down the second term, plus first term times what? Derivative of the second term. And we're all going to do them in the same order. If you're worried your derivative is wrong, I've got it on the board for you. Right, rule above it. Always, if you have to, write your little thoughts, write how the product rule is supposed to look. Now, when you start factoring and you're looking at the sets of parentheses, that's the first thing we'll look at. What power are you going to take each parentheses out to? The what power? The least, lowest, the least. You'll have better English than I have. The lowest power. Do not factor it out to a power other than the lowest power. Because we're hoping to get little powers of 1 all inside the bracket. We don't want anything with nasty powers in the bracket. How many people had the derivative right? Check your derivative on the board. How many people had the derivative right? Raise your hand. Raise it up high. Make your classmates feel bad if they didn't get it right. All right. Good deal. Line up your plus signs. And I always do the parentheses part with the powers first. I don't do all the little 2's and 3's. I try to get those big parentheses with the powers out of the way. Makes life easier. And I will say this, do not do so much in one step that you miss something here, because you're going to use the results later to do something else. So, go ahead and take the parts that have the negative exponents and move them to the denominator, just to make it look good later on. And then all I have to do is clean up what's in the brackets, right? I'll have negative x cubed and negative 3/4 x cubed, which is negative 7/4 x cubed. Make sure that x does not look like it's in the denominator. All right, please don't write where the x looks like it's in the denominator, because you don't want to take the chance on missing it there. And then we'll have plus 15/4 x, and then minus 4. Get all that distributive property stuff and collecting like terms, and there we go. That's probably not how the answer looks in the textbook, and I'm going to tell you about that. I mean, if you got something close to that, and you may have stopped here, right? Or you may have stopped and had this, and you just left that in the front, which is fine. But sometimes the negative exponents get in the way. Now, I'm not going to try to embarrass you. So I'm not going to pick up my green pen. If I was trying to embarrass you, I'd pick up the green pen like Captain Shreve. See, that'd be the embarrassing moment. Talk to me about this step. Anyone needs some information about this first derivative step? Seriously, does anyone? Everybody saw it was a product rule, right? They took the derivative of the first, wrote down the second, wrote down the first, and then took the derivative of the second. Okay? When you took the 5 minus x squared out to the power of negative 1/2, because negative 1/2 is smaller than what? The power of 1/2. And it made this one become a 1, because 1/2 minus negative 1/2. When you're factoring out, you're subtracting the exponents. So 1/2 minus negative 1/2 gave you the 1. And if you do it right, all these big sets of parentheses should have powers of 1. That makes it easy to collect like terms. So far, so good. Waiting for anyone to. Got to be a question. I just feel that someone's sitting there going, but Mr. Evans, I want to ask a question, but these other folks will laugh at me. No, they won't. I'll hit them with my shoe if they do. The only person allowed to laugh at you in here is me. Okay, well, these kids just seem like they know it, so let's go ahead and give them a good problem. Let's do something good. I have